You guys are working on your review for Chapter 3. That's on text page, what page is it? 182? Okay, 182. Question 8a. So this is a word problem, guys, and it deals with the population of a city. First off, it tells us that population is going to be represented at P at T. So this here equals population of a city. It also tells us in the question the variable T, which is used in P at T, represents a year in time. So it represents time, but it's in years, and it represents the year 2000. Yeah, that's right. So time in years. Important we know what these variables are in order to answer the question. They've also modeled the population of the city with this equation. It says P at T is equal to 14T squared plus 180T. No, 820T. I was way off there. And 42,000. Yep, that's right. Okay, so I'll read the question. Population of a city, P at T, is given by the function P at T. Here's our function. Is it 42,000 or 4,200? Oh, 42,000. Given by that function where T is time in years. Note that T equals 0 corresponds to the year 2000. All right, so we have all that information down. A says, when will the population reach 56,224? Provide your reasoning. Okay, so they're giving us a measurement or a number for a population. They're asking us when this population is going to be equal to 56,224. So in order to answer this question, I'm going to substitute that value in for this. So our population, P at T, we're going to substitute our new number in that they've given us. They've given us the number 56,224 is equal to 14T squared plus 820T plus 42,000. Okay. In order to do our factoring that we've been doing before, so in order to solve the values for these T's, we always have to make one side of the equation equal to 0, which means I need to move this 56,224 over to the other side. So when I move it over, it's going to become negative when it goes to the other side. Plus 42,000 minus 56,224. So we're going to simplify these two numbers here. 42,000 plus 820T. Subtract, what's that? 14,224? Thank you. There you go. So we have our new equation. It's set equal to 0. We simplify. In order to solve for the T's, we need to factor these two. So when I factor, what is my first step? I always try to find what? Anyone know? All right. So that's right. First thing we want to do is find a common factor. Now, these are some rather large numbers. So what I'm going to do is I'm going to work piece by piece through this. Instead of trying to find the greatest common factor right off the first bat, I know that 2 is going to go into all of these. So my very first step, I'm just going to take 2 out. It may be a larger factor, but I'm going to start small, little numbers at a time. So when I divide this by 2, 14T squared divided by 2, 7T squared, plus when I divide this by 2, 410T. And when I divide this by 2, it becomes 7112. Okay? Take a look at these numbers. I have a 7, 410, 7,112. Okay? 7 is a prime number. So unless I can take 7 out of these two, this is the greatest common factor I have. Does 7 go into this? No? Does it not work? No, it's a 6. Okay, so no, this is our greatest common factor. So now that we found our greatest common factor, let's keep our zeros on the outside. We just need to factor what's in these brackets here. Plus 410t minus 7112. This is going to be an intense question. So when we go to factor, we find the first factors. Factors of 7 are 1 and 7. Factors of 7,112. There are going to be a lot of them, okay? So we're actually going to have to list them in order to figure this out. And we know they're going to have to add up to 410. So we're going to quickly go. We know 1 times this is a factor, but that's definitely not going to get us to 410, okay? So we're going to have to look for other factors, and we're going to have to add up to 410. So instead of easy, pretty good. All right, so on our third try here, our factors of 14 and 508, we multiplied 7 times 14, we got our 98. 1 times 508 gives us 508. And we know that 1 has to be negative because this is a negative number. And in order for this to work, we needed the 98 to be negative, which means our 14 was negative. So when we go to write these numbers in, our first terms, we're going to have a 1x or just x, and we're going to have a 7x. Now our last terms, they got to go in opposite brackets of what we multiplied by. So I multiplied 7 times 14, or negative 14. So the negative 14 goes in this bracket, and this is our plus 508. So we have our 2 sets of factors now. Now I need to solve for my x's to find out when the population will reach that. Oh, undo that part. So the numbers we get, we make 2 separate equations. We have x minus 14 equals 0, and we have 7x plus 508 equals 0. So we need to solve for both x's. X is 14, sounds pretty reasonable. 7x is negative 508. X equals, what's negative 508 by 7? Anyone know? That's 7.182 point something something something. 72 point what? 57. Okay. So now that we have our answers, actually, let's keep going. Okay, so I have my 2 answers now. According to this, when x, or sorry, they were using t. So let's substitute t in. My fault. Sorry, guys. T is 14, and when t is negative 72.57. Now, these answers are actually numbers that we need to put into years. If we go right back up to the top, t is equal to, when t is 0, we're in the year 2000. So when t is 14, what year will we be in this case? 2014. And when t is negative 72, what year are we going to be in? Get a calculator out. What's 2000 minus 72.75? 1920, 27.25. So we're 3 months into the year. Okay, 3 months into the year of 1927. Let's take a look at these. They give us a population that's working from the year 2000. So which of these 2 answers is logical? We have a growing population. Which of these 2 answers is logical? 2014, that's right. The population is growing. So they've given us 2, which you're going to get on your test. You're going to get 2 answers. You have to be able to choose which one is a logical answer. This one here is the one that makes sense. Yes, Ian.